Hello everyone, welcome back. I'm Chayan Vinayak Goswami. In this video, we are going to take a look at the technique of traversing the hypergraph inside Maya scene. If you need to jump to a particular node to access its properties, how you can do it. With that, we would also learn the technique of reading and writing different attributes of different nodes inside Maya. For example, if you need to read width and height of a polyplane to plug them inside a separate node, how you will be able to read those properties. If you need to modify subdivision width and height of a polyplane, how you can do it. So let's get started and start learning these techniques. So here I have opened new session of Maya and I will create a polyplane, and after creating a polyplane I would set its properties, or I would set its attributes. I would set its width to 10, height to 15, subdivision width to 20, and subdivision height to 25. After setting these properties, I will write some code. And initially, I would follow the same steps which we followed in the previous chapter. We will create a mSelection list, we will create mObject and mDagPath, and then we would request mSelection list to give us dependency node of polyplane inside mObject or mObject type object, and DagPath inside mDagPath type object. So let's get back to Maya and start writing some code. So let's get back to Maya and start writing some code. So here I'm in script editor and I will import open Maya module, maya.openMaya as open Maya. And I would also keep executing these commands so that we can see their results. After importing open Maya module, I will create mSelection list. And I will name this variable as lowercase m uppercase SEL, and it would be open Maya dot mSelection list type object. After that, I would add my polyplane inside mSelection list. So I will get the name of polyplane from my outliner, pplane1. I would execute that command as well. So first step, we created a selection list. The second step is creating mObject and mDagPath. I will call my mObject type object as lowercase m uppercase O bj, and it would be open Maya dot mObject. Let's create that. After that, create mDagPath type object. Open Maya dot mDagPath. Let's create that too. Okay. After that, we would request selection list to give us dependency node inside mObject and DagPath inside mDagPath. Request dependency node, DagPath of the object. Okay. And how we would request it? mcell.get depend node. We need the dependency node of the 0th object of mSelection list. And where do we need it? We need it inside mObj. In the similar way, we need the DAG path, we will get that using function get DAG path, and we need the DAG path of 0th object inside mDAG path. Okay, so we have gotten DAG path and dependency node, but we also want to verify it if we have gotten the correct path or not. So mDAG path dot full path name is a function to retrieve the full path name, which is very clear by the function name. So we will print that, and it has given us the p-plane 1 because this is the mesh which is present at the root of outliner, so there is no parent of it. So it has given us p-plane 1, and that sounds right. Okay, now before we write our further code, we would understand a couple of terms on our blackboard, and then we will come back and write more code. So one of the terms we will understand here is Mfn, which stands for model function set. What is Mfn, or what is function set? As its name say, it's a set of function, it's a class that takes a certain input and provides us ways of performing different operations. It provides us the function to perform different operations. One more thing to remember here is it's kind of a key and lock mechanism. Only a certain type of inputs can fit inside a certain type of function sets. So for example, if it is a function set of meshes, only the mesh type objects would be able to fit in here. If you would try to fit in a different type of object, which is not a mesh, you would receive an error. So you would have to be careful when you will be using the function set, and you would have to remember, or you would have to understand what you are fitting in here. Now we will understand what is Mfn Mesh. So a function set that works on a mesh type data. So the input we will provide here is a mesh type data, and it would give us the functions to create, modify, and retrieve mesh specific data. It also provides us the function sets, or the function to add the edge, to add faces, or add the subdivision to a mesh. If you want to create a mesh using number of vertices, you can do that using Mfn Mesh function set. And it provides us various different methods as well, and we will take a look at Mfn Mesh when we will write more code. The second function set we will study here is Mfn Dependency Node. So Mfn dependency node is a set of functions that takes dependency node type data and provides us the functions for creating, modifying, and retrieving the dependency graph nodes. One thing to remember is we cannot break the connections of a dependency graph using the Mfn dependency node. So creating, modifying, retrieving dependency graph. And also, when we would provide these function sets with the input, we would not directly give them a mesh or a node or attribute or anything else. The two usual way of providing the inputs to the function sets are mObject and mDecPath. So we would provide them the input through a handle, which can be mObject and it can be mDecPath. So these are the two usual ways of providing inputs to the function set. Okay, now we can get back to our code and write few more lines and understand back few more things in our Blackboard. So first we would create a Mfn function set first, Mfn Mesh, and I would call it lower Mfn Mesh. And how we will create Mfn function set is openMaya dot Mfn Mesh. Okay. So now we want to know what kind of input does it take. So it takes the mDecPath type input as well as mObject. To verify it, you can go to the API reference, Maya API documentation, and if you would look for Mfn Mesh, you would see a couple of functions here, and which would tell you Mfn Mesh takes mObject and mDecPath. And also take a look at the documentation of mDependency node, and here we would see that it just takes mObject, so we can't provide the mDecPath to it. So get back to Maya and provide the input to it. So to Mfn Mesh, I will provide mDecPath because it takes both, so I would recommend providing mDecPath. Okay, our function set has been created. There is a way to verify the function set on which mesh type object it is operating, and for that it's the same Mfn Mesh full path name, print full path name, and it's working on pplane 1, pplane shape 1, so it's working on the shape node of the pplane 1. Okay, so the fourth step is we created mesh function set. Okay, and then we will create dependency node function set. Okay, and how we will create that? Mfn depend node. This is the name of the variable I'm giving, and we will create it using openMaya.mfn dependency node. And we know that we can provide m object type input to it, so I will provide m obj. Let's execute that. So this has been created as well. Okay, and we want to verify this function set too, mfn dependent node, and the function to verify this is just name, because it doesn't take DAG path, so it can't provide you full path name. That's why the function for retrieving the object it's working on is name. So it has given us the name pplane. Okay, so we wrote, or we created function sets for dependency node and mesh type data, mesh specific data. Now we will go back to our blackboard and understand few more terms, and we will write more code. And the term we will discuss here is mplug. What is mplug? Mplug is a class that provides us functions on operating on a plug type data. Okay, and now what is a plug? So we have a dependency node here, that's a node, and we know that nodes have attributes. So these are the attributes of a node. And plugs are the handles to create, modify, and access the attributes of a node. So we would, in later videos, we would dissect a node a little bit more, but now we know that plugs are the handles using which we can create, modify, or access the attributes. So whenever we will be accessing the attributes, we will be accessing them through the plugs. At the user level in Maya, plugs are transparent. So whenever we are operating on any of the node here in Maya scene, we just see the attributes here, and the mplug layer stays hidden. We just modify the attribute, and we think there is no concept of mplug here. But in open Maya, or inside Maya core, or in the background, the attributes are accessed through mplugs, or the plugs. And the plugs are of two types. They are network plugs and non-network plugs. So network plugs are the plugs of dependency node. So they are dependency node plugs. And non-network plug is a user-defined plug. So now we understand what is plug and what is mplug. And now we will see what is mplug array. Mplug array is a class that provides us method of operating on array of plugs. So if we have an array of plugs, then we will use a class mplug array. So let's get back to Maya and start using what we have just learned. So I'm here in my Maya code and I have Mfn function set and Mfn dependency node function set. Okay, now what I want from Mfn Mesh, if I would open the hypergraph here and select the polyplane, we see that this is the complete hypergraph for a polyplane. This is the transform node, this is the shape node, this is the shading group, and this is the history. So what I want from this Mfn Mesh, which is operating on p-plane shape 1, which is operating on this node active, I want to know the connections of this particular node. If we can see here that this node is connected with two different nodes, and the connection bridge is p-plane shape 1 inst obj groups 0, which is connected to initial shading group dag set members 0, and the incoming connection is polyplane 1 output, which is coming to p-plane shape 1 in mesh. I want to know all those connections because my goal is to modify the subdivision height and subdivision width attribute of polyplane 1. If I'm actively working on p-plane shape 1, then at a certain point I want to reach to polyplane 1, and then I would reach to its attribute. So my first step would be to get all the connections of p-plane shape 1, and to get all the connections, so the sixth step here is get all the connections of a shape node. For that I will use Mfn Mesh, and I will use a function which is get connections, and it will require an input because it would give us all the connections, so it would give us all the handles of the attributes, and we will take that returned value inside a mPlugArray type object. So how we will create mPlugArray type object is using openMaya .mPlugArray. So this object is now array of mplug type objects, and I will provide this input here. To understand what I just said, I will show you a diagram on the blackboard. So this is the hypergraph which we just saw in the Maya scene. And if we will dissect it a little bit more, we would see that we have nodes, then we have attributes, and then we have our plugs. And all the connections have been made through the plugs, right? So when we would want all the connections of a node, it would give us all the plugs. So in this situation, it would give me this plug, and it would give me this plug, right? Okay, so that's what we are doing here, is we are creating an array of mPlugs, and then we are asking to give all the connections which will be returned to us in the form of a plug, of plugs, an array of a plug. Okay, so let's execute these two comments, and now we have all the connections inside mplug array. We want to verify everything because we are learning. So first thing I'm going to do is I'm going to know that how many connections did it return, and for that I will use a function called as length. So the number of plugs returned would be the length of this array, which is 2, and we just saw that there are 2 different connections. Now I want to also verify the names of the connection, so I will print them mplug array 0th element and the name. In the similar way, I want to print mplug array first element and the name. Let's execute these 2 commands. So the first connection it printed is inst object groups 0, which is this one, and the second is in mesh, which is this one, right? So we have gotten the connections. So we have gotten the connections of this node, and as we said, the final goal of instructions, or our set of instructions, would be to jump to this node. And to jump to this node, we will use the help of this bridge, which is this connection bridge. So far we have p-plane shape 1 in mesh, and through that, which is the destination of this bridge, we want to reach to the source of this bridge, right? So for reaching to the source of a bridge, we will use a function which is a function of mplug class, and the function name is connected to. So as I said, it's a function of mplug class. So when you are using mplug array, we will use the 0th element or the first element, which is in mesh, right? So we don't want to deal with this connection at this point because there is no goal of reaching to the shading group. We want to reach to the polyplane 1, and we want to use in mesh plug, right? And the in mesh plug is array 1. So we will use a function which is called as connected to, which takes couple of inputs, and in the similar way as get connections, it would return us, or it would give us the values inside mplug array. So we will have to create one more plug array, mplug array, and we would name it as mplug array connections. Okay, connections, which is openmaya dot mplug array. Okay, if we will take a look at the definition of this function, we will see that it takes 3 different arguments. First, it takes mplug array, to which it would return all the connections. Then it takes 2 Boolean arguments. As destination, true means we want to find out all the connection to which this attribute is a destination. So if we'll go back to Maya and see the hypergraph and see this bridge, the starting point is a source and this ending point is a destination. So do we want to find out all the connections to which this attribute or this plug is a destination, or do we want to find out all the connections to which this plug is a source? So we know that in this case it's a destination. So the first thing we are going to provide it is our mplug array connections, or I mean, if you want to shorten it up, you can just use mplug array 2 and mplug array 2 here as well. Longer variable names are first difficult to write, but in future, whenever you will have to take a look at your code, you would understand them quickly. So I provided mplug array2, and the second argument is as source, which is a boolean. It's a as destination. So here it's as destination, and we know that in the hypergraph this at plug is the destination. So here I would provide true, and then I would provide false. Okay, now it would give me all the connections to which this plug is a destination. So it has given me the error mplug array2 is not defined because I did not execute this command. So I executed this command and got the connections. Okay, now I again want to check the length of mplug array2. One thing to remember, Python users, that we cannot do this here because this is not a Python array. This is a specialized API array, which to find out the length of which we will use the function length. Okay, and it has given us 1. So I will comment it out, cannot be used. So it has given me the length 1, and I know that it is the only connection of this plug. Okay, I want to verify the name of it. Print mplug array2 zeroth element dot name. Polyplane 1 output, and if we will drag our mouse onto this bridge, we will see it is connected to polyplane 1 dot output. Okay, get back to our diagram. So we started from the node because our Mfn Mesh was working on the shape node. Then we reached to this plug. Then we reached the plug of polyplane 1 node, and eventually our goal is to reach to this node. So we are here at this point. How we can reach to this plug, and after reaching to this plug, how we can reach to the different attributes of this plug. For example, this plug has attributes subdivision width. This plug has attributes subdivision height, width, height. So these are the attributes which we want to access it and we want to change. So far we have reached to polyplane 1 dot output plug. If we want to reach to a node, there is a simple function which is dot node, and if I will execute that, it would give me m object of this node. Okay, and we know that we have a dependency node, and this m object has a dependency node information for us. So in that case, I will create a new dependency node function set. So I will copy these two lines, I will paste them here, and I will call it function set2, and instead of passing m object, I will pass m object of pplane 1. I would not call it as plane 1, polyplane 1, because that doesn't make much sense. So I will call it m object 2. Okay, I will execute this command and I will copy it, paste it here. Okay, I want to verify the name of it. Print name. We have reached to the node which is polyplane 1. Now we want to access its attribute, in this situation, we know what attributes do we want to access. So the first attribute I want to access is width. And I will call it as mplug underscore width. And through this function set, how we will find that plug? We will find that plug using a simple function, find plug. Which plug do we want to find out? I want to find out the plug width. Let's execute it. And okay, so it's not a readable information because it's a plug. It is not an integer value. We will retrieve integer value later. First, let's create all the plugs we need. And I also want to find out height. In the similar way, I want to find out the subdivision width and subdivision height, but we would retrieve them later. So execute these two commands, and I want to read the integer value of these two plugs. Mplug width dot as int. I need the integer value, so I will use a function called as int. It has given me 10, and I will verify it. Width, it is 10. In the similar way, I will find out the height. Print mplug underscore height as integer. It has given me 15, which is the height, and all the values are correct. Later on, we want to find out the subdivision width and subdivision height. So for that, I will create mplug sub width mfn dependency node dependent node 2 dot find plug subdivision width. And in the similar way, I will find out subdivision height. So I have values, or I have plugs of these two attributes. Now I want to set the new value to these attributes. For setting the new value to these attributes, I will bring this window so that you can see the complete code. So what I have written is mplug subwidth mfn dependent to find plug and the name of the attribute, which is subdivisions width and subdivisions height. To set the value, I will use a function called as mplug sub width set int, because I'm going to set the integer value of it, and I want to set the subdivision width to 10. And in the similar way, I would want to set the subdivision height to 10 as well, but let's first execute this command and check. So it has set our subdivisions width to 10, and now I want to set mplug sub height int 10. So I have also set the subdivision height to 10. So we have seen what are the function sets, what are plugs, how they are connected to the attributes, and how to access a particular attribute of a node and how to modify that. So thanks for watching the video, and keep practicing, keep writing more code, and we will continue our videos with more complex things. Bye.